In physics, we typically, as we study the motion of objects, we typically like to have a graph of the object's motion that we can look at. What the graph is just a visual representation of either the position of the object or oftentimes the velocity of the object at any given moment in time. I first want to spend a little time talking about what a position time graph would look like. So a position time graph is basically a graph where you have the position of the object on the y-axis and the time at which the object is located at that position on the x-axis. You know, this is basically like a true dependent, independent variable type of thing. The position is the dependent variable and the time is the independent variable. You know, where the object is depends on what time that you're looking at. The particular graph that I have shown right here shows that an object starts off in this position right here at time 0. It is some distance away from, you know, what we would consider the origin. The origin here is the intersection between the x and the y-axis. Now the question is, what is the origin? Well, if we're talking about using motion detectors to measure the position of something, the motion detector itself is the origin. If you were talking about somebody running a race, the starting line would be the origin. This graph would show some object actually not starting at the starting line, but starting some distance away from the starting line in the positive direction. If I wanted to show the object starting at the origin, then my graph would have been like this instead. But back to the original graph that I have an object that starts at the origin, and then as time goes by, it just moves to distances further away from the origin. So we would say that this is an object moving in the positive direction away from the origin, and because this rate of change is constant, we would basically say that it moves at a constant rate of speed. Okay. This graph down below, the second graph I have, actually shows an object that's starting away from the origin, and then as time goes by, it's actually moving closer to the origin. So in that direction, in this situation, it still has a constant rate of speed, but this actually would indicate that it had a negative rate of speed. Okay. One thing that's very important about graphs of motion is that the slope of a position time graph will actually tell you something very important. The way you always find any slope is you just take the change in the y variable and you divide by the change in the x variable. Oftentimes we use the term rise over run. And in this graph, that would be change in position over change in time. And change in position over change in time, by definition, is what speed is. And so one of the things we learn right away is that the slope of a position time graph is speed. Not only does the value of the slope tell you how fast it's going, but the sign of the slope, you know, if it's a positive slope like here, or if it's a negative slope like I have here, the sign of that slope tells you if it has a positive velocity or a negative velocity. Okay, so let's use what we've learned in the previous 3 minutes to answer a pretty basic question about a graph of motion. This question says, which graph shows an object moving with a greater average speed? For this problem, we want to assume that the axis scales are the same. So I'm going to give you a moment. I would pause the video and think about what you would choose as the right answer. And when you think you have the right answer, hit play again. Okay, so in this particular question, the right answer is letter A. The reason letter A shows an object moving with a greater average speed is because simply the slope of this line is greater than that slope. It was pretty important that we assume that the axis scales were the same, because that would indicate just by visual inspection that A had a greater slope than B did. Okay, so as I've already indicated, the negative sign of that graph tells us something pretty important. One of the things that's very important to keep in mind is that a negative sign in physics actually indicates the direction of motion relative to other factors. In a math class, you might have been taught that a negative number was like an imaginary number, or that it didn't actually mean something. But in physics, negative actually indicates direction. You know, if you thought about good old-fashioned number sign, or number lines that you learned in elementary school. If you took a +2 and then you added a -5, that would be the same as subtracting 5, which would give you a negative number. You're really moving along one direction of a number line, and that's pretty much how we think about it in physics as well. So, whichever direction that you define as being positive in any problem, then that would tell you that any positive motion would be motion in that direction. If you have a negative sign, then that indicates that you're moving against what you would call the positive direction. So, I don't know, some examples that we'll go over in the future involve up and down motion. Up motion in physics is typically defined as the positive direction. This would indicate something moving up in the air, straight up in the air in the positive direction with some positive speed. And this would indicate something falling down in the air, but with a constant speed. I don't know, maybe this would be a parachuter after he's popped his parachute and he's floating towards the ground with a constant speed, something like that. This is getting closer to the origin logically being the Earth. The last interesting thing to talk about with position time graphs is what happens when something is not moving at a constant speed. So consider this position time graph. You can see that whatever the object is starts here, some distance away from the origin, and at first it looks like it's pretty much just staying in the same place in time. But then as time goes by, it actually starts to move away from the origin, and it's actually moving away from the origin at different rates. In this interval right here, it's moving away from the origin, but in this interval 3, it now has a greater positive slope, which means it's moving away from the origin faster than it was before. This curving position time graph that we see indicates that there's a change in velocity, and a change in velocity is defined as acceleration. So let's check your understanding of what position time graphs show of an object's motion. This question, which section of the graph below shows when the object is at rest? Hit pause on your video and think about it for a moment, and when you're ready, hit play again. The correct answer is in letter B. In letter B, it shows that the object is in the exact same position over time, which means it's at rest. Question 3 says, which section of the graph shows when the object has a constant negative velocity? Hit pause on your video and hit play when you're ready to hear the answer. The correct answer here is letter C. In letter C, the object has a constant negative velocity, and that primarily is because on this graph, the position time graph has a negative slope. A negative slope corresponds to a negative velocity, and the fact that the slope doesn't change means that it's constant. Okay, in this question it says which section of the graph shows when the object is accelerating. Hit pause on your video and hit play when you're ready to hear the answer. The correct answer here is letter D. The definition of acceleration is a change in velocity. And on a position time graph, the way we see a change in velocity is to see a slope that is changing. This has a constant slope. This has a constant slope that is 0. This has a constant slope. This has a changing slope. The slope of this graph is decreasing over time, which tells us that the object is losing speed. I would actually say that this object had a fast negative velocity, and it eventually comes to rest. Last question, and this one's not in the notes that we have printed. On your own paper, draw a position time graph for an object that starts at the origin and moves away from the origin. The object starts with a fast speed and then slows down and stops. Draw your attempt at this graph on your own paper. Go ahead and hit pause on the video, and when you're done, hit play again to see what it really should look like. Okay, so the correct graph here would go like this. You need to have a position time graph first. So the y-axis and the x-axis will represent position and time. Be sure to label the axis appropriately. Normally I would put a unit here with these, but since this doesn't have a unit to it, I just use the words position and time. So if the object starts at the origin, then I know it's going to start right here. And because it moves away from the origin, it's going to move off in this direction. The fact that it starts with a fast speed and then slows down and stops means that it's going to start off with a steep slope, and that slope is gradually going to decrease until it comes to zero. I'm trying to show something that would be fairly uniform because in physics that's what we study. That's it for this video. If you need some help with velocity time graphs, you can look at the next video in Untitled Graphing Motion Velocity Time.